Welcome to Reddy Technologies Manual Testing Quick Guide or Quick Reference. Say, I think all of you familiar with this concept. Software testing can be done in two ways. One is manual testing, another is automated testing. Testing computer software manually without using any test tool or test script is called manual testing. Next, testing computer software using any test tool or test script is called automated testing. Okay, say for learning automated testing, manual testing is not mandatory, but if you learn manual testing before learning automated testing, then you can easily understand the software testing methodologies, terminology, processes, etc. So, before learning automated testing, learn manual testing. If you want to learn only manual testing, learn. But nowadays, for getting job and surviving in job roles, automated testing is important. Not mandatory, but important. Okay, manual testing quick guide or quick reference. See, just a minute. See, manual testing index or content. I planned 6 chapters for this quick tutorial. One is software development life cycle. Next, software test levels, software test types. Fourth one, software testing techniques. Fifth one, software testing life cycle or software test process. Important one, software testing life cycle, SDLC or software test process. Next, software test documents. See, software test document actually is not a separate chapter. In software testing life cycle, SDLC, we prepare these documents, but in order to focus on these documents, I created a separate chapter for software test documents. See, first chapter, software development life cycle, SDLC. Actually, it is developers chapter. Why testers need to learn this one? Software testing is an integral part of software development life cycle. So we need to familiar with software development life cycle, but our main area is software testing life cycle. Next, test levels, test types, test techniques, all are supporting concepts. Next, first chapter, software development life cycle. See, phases of we have 6 phases of software development life cycle. These phases may vary from one organization to another, but the purpose is almost all same. What is the purpose? Develop and maintain quality software. See, what are the important phases in this? What are the phases in this software development life cycle? Requirements gathering, analysis, design, software design, coding or implementation, or you can say development. Next, fifth one, software testing. Sixth one, release and maintenance, or you can say deployment and maintenance. Say, it is general software development life cycle. We have various software development life cycle models in the industry. Waterfall model, V model, spiral model, Agile model, etc. Software development process varies from one SDLC model to another. Next, requirements gathering. First phase, initial phase of this life cycle, requirements gathering. See, requirements gathering is the most important phase in software development life cycle. Business analyst collects the requirements from the customer or client as per the client's business needs and documents the requirements in the business requirement specification and provides the same to development team. One small note, document name. Document name may vary from one organization to another. Some examples are customer requirement specification, CRS, business requirement specification, BRS, business requirement document, BRD, etc. Okay. Suppose our planned software is not intended for a single customer and the software product for multiple customers, then business analyst or business team collects requirements from the market and also evaluate other similar products in the market. Key role in this phase is business analyst, and outcome of this phase is business requirement specification. Next, second phase in this software development life cycle, analysis. Once the requirements gathering is done, the next step is to define the document, the product requirements, and get the approved by the customer. This is done through SRS, software requirement specification. See, business requirements, software requirements. Business requirements converted into software requirements. Business requirements, non-technical document. Software requirement specification, technical document. SRS consists of all the product requirements to be designed and developed during the project life cycle. Key people involved in this phase are project manager, business analyst, and senior members of the team. The outcome of this phase is software requirement specification, SRS. Okay. Next, third phase, design, software design. In design phase, senior developers and architects, they give the architecture of the software product to be developed. It has two steps. One is HLD, high level design or global design, and another is LLD, low level design or detailed design. High level design, HLD, is the overall system design, covers the system architecture and database design. It describes the relation between various modules and functions of the system. Next, LLD, low level design, is the detailed system design, covers how each and every feature in the product should work and how every component should work. The outcome of this phase is HLD, high level document, and low level documents. High level document is single, low level documents multiple. With works and input to the next phase, coding or implementation or development. Next, fourth phase in this life cycle, coding or implementation. Developers, senior developers, juniors, freshers involved in this phase. This is the phase where we start building the software and start writing the code for the product. The outcome of this phase is source code document, SCD, and the developed product. Next, fifth phase in this software development life cycle, testing, software testing. Once the software is complete, then it is developed, then it is deployed in the testing environment. The testing team starts testing, either test the software manually or using automated test tools, depends on the process defined in SDLC. Testing is done to verify that the entire application works according to the customer requirement. During this phase, testing team may find defects which they communicate to developers. The development team fixes the defects and sent back to testing for a retest. This process continues until the software is stable and working according to the business needs to the system. See, in this general software development life cycle, we have one phase of software testing, but nowadays we have multiple levels of software testing, 4 levels of software testing. Okay. Next, second chapter, software test levels. There are 4 levels of software testing: unit testing, integration testing, system testing, and acceptance testing. See, in olden days, only one level of software testing after coding or implementation or development. But nowadays, we have different levels of software testing in order to improve the quality of software products. See, here 4 levels of software testing. Testers may vary from one level to another. For example, unit testing, testers are developers. In system testing level, testers are independent testers like you people. Next, fourth one, in acceptance testing, testers are end users. Integration testing, in some companies, testers conduct integration testing. In some companies, developers also involved in this integration testing. But in unit testing, developers conduct unit testing. Independent testers conduct system testing, testing on integrated system. Next, end users conduct acceptance testing. Next, user acceptance testing is there. User acceptance testing is subset of acceptance testing. That's it. Okay. Unit testing. What is unit testing? The most, say, as a test engineer, you need not involve in unit testing, but know the concept. Our area is system testing, third level. System testing, testing on integrated system, but know what is what in unit testing. What is unit testing? The most basic type of testing is unit or component testing. Unit testing is a level of software testing where individual units or components of software are tested. And the purpose of unit testing is to evaluate that each unit of software performed as designed. Unit or component testing may include testing of functionality and specific non-functional characteristics such as resource behavior, performance or robustness testing, as well as structural testing. Test cases are derived from software design documents. Next, it is normally performed by software developers using white box testing techniques. In rare cases, it may also be performed by independent software testers. Next, integration testing, second level. Integration tests interfaces between components, interactions to different parts of a system such as an operating system, file system, and hardware or interfaces between systems. Integration testing is often carried out by the integrator, but preferably by a specific integration tester or test team. Test drivers and test stubs are used to assist in integration testing. Integration testing can be conducted in 2 stages for some applications: component integration testing after unit testing, system integration testing after system testing. Next, system testing level. System testing. the process of testing an integrated system to verify that it meets specified requirements. System testing should investigate both functional and non-functional requirements of the system, and testers may also deal with incomplete or undocumented requirements. Next, system testing requires a controlled test environment as well as stable software build, and the test environment should correspond to the production environment as much as possible in order to minimize the risks. Normally, independent testers perform system testing using black box test design techniques. Next, last one, acceptance test level. Acceptance testing, test level. Acceptance testing is a level of software testing where a system is tested for acceptability. The purpose of this test is to evaluate the system's compliance with the business requirements and access whether it is acceptable for delivery. The acceptance test has two stages. First one is alpha testing. This test takes place at a developer site. A cross section of potential users and the members of the developers organization are invited to use the system. Developers observe the users and note problems. Next, beta testing or field testing sends the system to a cross section of users who install it and use it under real world working conditions. Say we have different acceptance tests. User acceptance testing is performed by the end users of the software. The user acceptance test focuses mainly on the functionality of the system, and the another one, operational acceptance test, also called production acceptance test, validates whether the system meets the requirements for operation. The operational acceptance test may include testing of backup and recovery, disaster recovery, and maintenance of the system. Next chapter, software test types. See, a test type is a group of test activities. See in the previous chapter, this is the sequence. Say first unit testing on individual units. Next, integration testing. Next, system testing on integrated system. After system testing, finally, the acceptance testing. This is the sequence. Next, software test types. See, already I told, a test type is a group of test activities aimed at testing specific characteristics of a software system or a part of a system based on specific test objectives. Such object may include functional, non-functional, etc. See, basically, we have two types of testing. Subtypes are there. One is functional testing, another is non-functional testing. But according to international syllabus, ISTQB like certification syllabus, we have four types of testing: functional testing, non-functional testing, change-related testing, or functional testing, non-functional testing. Third one, structural testing or white box testing. Fourth one, change related testing or regression testing. But focus on first two types. Why? Third type, structural testing. We need not perform this testing. Developers perform this type of testing. Next, fourth one, change related testing. Say, as part of functional testing or non-functional testing, we conduct change related testing. Say, if you find defects in the AUT, application under test, after receiving the modified build, definitely we conduct change related testing. That is part of functional testing or non-functional testing. So focus on functional testing, non-functional testing. What is functional testing? Functional testing of a system involves tests that evaluate functions that the system should perform. Functional requirements may be described in work products such as business requirement specifications, epics, user stories, use cases, or functional specifications, or they may be undocumented. The functions are what the system should do. Functional tests should be performed at all levels of testing. Testers may vary: unit testing, integration testing, system testing, and acceptance testing. See, functional testing can be conducted in all levels of testing: unit testing, integration testing, system testing, and acceptance testing. So the focus is different at each level. Functional testing considers the behavior of the software, so black box techniques may be used to derive test conditions and test cases for the functionality of the component or system. See, functional test design and execution may involve special skills or knowledge, such as knowledge of the particular business problem and the software solves. Next, non-functional testing. Non-functional testing of a system evaluates characteristics of system and software, such as systems and software, such as usability, performance, security, reliability, availability, etc. Non-functional testing is the testing of how well the system behaves. See, contrary to common misperceptions, non-functional testing can and often should be performed at all test levels and done as early as possible. The late discovery of non-functional defects can be extremely dangerous to the success of a project. Black box testing techniques may be used to derive test conditions and test cases for non-functional testing. For example, boundary value analysis, equivalent classes, boundary value analysis can be used to define the stress conditions for performance tests. Next, the thoroughness of non-functional testing can be measured through non-functional coverage. Non-functional coverage is the extent to which some type of non-functional element has been exercised by tests. Non-functional test design and execution may involve special skills or knowledge, such as knowledge of the inherent weakness of a design or technology. Next, third one, structural testing or white box testing. Structural testing or white box testing derives tests based on the system's internal structure or implementation. Internal structure may include code, architecture, workflow, and data flow within the system. Next, fourth one, change related testing or regression testing. When changes are made to a system, either to correct a defect or because of new or changing functionality, testing should be done to confirm that the changes have corrected the defect or implemented the functionality correctly and have not caused any unforeseen adverse consequences. Confirmation testing. After a defect is fixed, The software may be tested with all test cases that failed due to the defect, which should be re-executed on the new software version. Confirmation testing, or you can say retesting. Next, regression testing. It is possible that a change made in one part of the code, whether a fix or another type of change, may accidentally affect the behavior of other part of the code, whether within the same component in another component of the system or even in another systems. Note, confirmation testing or retesting and regression testing are performed at all test levels. Next chapter, software test design techniques. Software testing techniques. What is test design techniques? A test design technique is used to select a group, a test design technique is used to select a good set of tests from all possible tests for a given system. Why do we need to use test design techniques? Exhaustive testing is not possible. So we need to use test design techniques in order to reduce the size of the input. What is exhaustive testing? Exhaustive testing is a test approach in which the test suite comprises all combinations of input values and preconditions. Exhaustive testing is not recommendable due to time and budget consideration. Exhaustive testing means testing with all possible inputs and preconditions. It is impractical. So we use tested design techniques to reduce input. Okay, once again, exhaustive testing is not possible. So we need to use tested design techniques in order to reduce the size of the input for execution. Next, we have two categories of techniques: static and dynamic test design techniques. First, static techniques. Say, testing of the software documents, manually or with set of tools, but without executing the software. See, static testing means testing software documents without executing the software. We have two types of static testing techniques: reviews and static analysis. And we have different types of reviews: informal review, walkthrough, technical review, and inspection. Next, dynamic test design techniques. Say, the software is tested by executing it on a computer. Static testing software documents. All documents are correctly prepared or not. Dynamic testing software. The software is tested by executing it on a computer. Next, categories of dynamic test design techniques. See, we have three subcategories in this dynamic testing techniques. One is specification based or black box techniques. Second one, structured based or white box. Third one, experience based techniques. You need not consider structure based or white box test design techniques. Developers use those techniques. As a test engineer, in formal testing, you use black box testing techniques. In informal testing, you use experience based techniques. Structured based or white box testing techniques are statement testing, decision testing, condition testing, multi-condition testing, etc. There is developers activity. Next, our area is specification based or black box techniques. We have different software test design techniques. Important techniques are equivalent partitioning, boundary value analysis, decision table testing, state transition testing, and use case testing, etc. Next, experience based techniques, error guessing, exploratory testing. See, due to less documentation or no documentation, no time, no budget, etc., companies prefer experience based testing, exploratory testing. Using previous experience, we have to conduct what is that one? Exploratory testing. That is informal testing. Next, important one, software testing life cycle. Heart of manual testing. Heart of software testing. Software testing life cycle. SDLC, or you can say software testing process. Okay, there are different phases in software testing life cycle which are given below. Requirements analysis, test planning, test design and development. Some are saying just a test design. Okay. Next, fourth phase, test environment setup. Fifth phase, test execution. Last phase, test cycle closure. See, during this in this software testing life cycle only, we prepare test documents like test plan, requirements traceability matrix, test case, test defect report, test metrics report, test summary report, etc. Testing documents. Okay. Say first, requirements analysis. In this requirements analysis phase, the team studies the requirements and identify the testable requirements. Here, entry criteria is requirements document available, both functional and non-functional requirements. Application architectural document or product should be available. Next, exit criteria for this phase, RTM, requirement traceability matrix, should be signed off and the customer should sign off on the test automation feasibility. Next, the activities of this phase are identify types of tests to be performed, risk analysis, prepare requirements traceability matrix, RTM. Next, identify test environment details. Next, automation feasibility analysis, optional. Next, deliverables in this phase, requirement traceability matrix document, RTM. Next, automation feasibility report, optional. Next, second phase, test planning, software test planning. In this phase, the test manager or test lead or team lead, the designation depends on your company. In this phase, the test manager or test lead prepares the test plan and test strategy documents. Entry criteria, requirements document, requirements traceability matrix, and automation feasibility report. Exit criteria for this phase, approved test plan document, test strategy document, and effort estimation document. The activities in this phase are selection of testing approach, test estimation, team formation, preparation of test plan and test strategy documents, configuration management planning, resource planning, test tool selection if required, next training requirement. Next deliverables in this phase are test plan and test strategy documents, next test estimation document, etc. Next third phase in this software testing life cycle or software testing process. Heart of the software testing is test design and development. In this test design phase, testers prepare test scenarios, test cases or test scripts and collect test data based on the requirements documents and test plan. Entry criteria for this phase: requirements documents, RTM, requirements traceability matrix and test plan, next automation analysis report, etc. Exit criteria for this phase: reviews of test cases or test scripts if automation and test data. Next activities in this phase are derive test scenarios, test case documentation, review test cases, update RTM, map test cases to requirements in RTM. Next, creation of test scripts if required. Next, collect test data, etc. Next, deliverables in this phase: test cases, test scripts if automation applicable. Next, test data. Next, fourth phase: test environment setup. It is combination of hardware and software environment on which the tests will be executed. Test environment supports test execution with software, hardware and network configured. See once again, test environment supports test execution with the software, hardware and network configured. Test environment configuration must mimic the production environment. Readiness of the test environment can be validated by smoke testing performed by the testing team. Next, entry criteria: system design documents, architectural documents of the application and the environment setup checklist, provision of test plan, readiness of smoke test cases and preparation of test data. Exit criteria of this phase: test environment should be ready and smoke testing should be performed successfully. Activities: set up test environment and test data, verify test environment by conducting smoke tests. Deliverables: test environment ready with test data setup, smoke test results. Next, fifth phase: test execution. In this test execution phase, the test cases are executed in the testing environment. While execution of the test cases, the testing team may find bugs which will be reported. Bugs are fixed by the developers and they are retested by the testing team. First, entry criteria: test plan document, test cases, test data and readiness of test environment. Next, exit criteria: test case execution report, defect reports, RTM, updated requirements traceability matrix, activities, execution of test cases, document test results and log defects for failed cases, update RTM, map defects to test cases in RTM, retest the defect fixes, track the defects to closure, deliverables, test execution report, updated test cases with results, completed RTM with the execution status, next opened and closed bug reports. Next, last phase of this software testing life cycle, test cycle closure. Testing team will meet, discuss and analyze testing artifacts and evaluate test cycle completion criteria, identify strategies that have to be implemented in future and taking lessons from the current test cycle. Entry criteria, test case execution report and opened and closed defect reports. Exit criteria, test closure report signed off by client and test metrics report. Activities, important activities in this phase are evaluate test cycle completion criteria, prepare test metrics, documentation of the learning from the project, prepare test closure report. Deliverables, test closure report, next test metrics, etc. See, in the software testing life cycle or software testing process, this software testing life cycle or software test process is for conducting software testing in system testing level, and it is manual testing process. Next, software testing documents. I've already told, say, we create and use software testing documents. We create and use test documents before, during and after software testing. In software testing lifecycle or SDLC or software testing process, we create and use test documents. Now I am focusing this concept. See, once again, we create and use test documents before, during and after software testing. See, we have several test documents: test policy, test strategy, system test plan or test plan document, requirements traceability matrix RTM, test case, test metrics report, defect report, test summary report, etc. See, important are test plan document. First, test plan template. See, test plan template may vary from one company to another. I am explaining one ideal test plan. See here, fields are test plan ID, introduction, test items, references, features to be tested, features not to be tested, test approach, entry criteria, exit criteria, suspension criteria, when to suspend the testing temporarily. Next, roles and responsibilities of team, schedule, training, test environment or test lab setup, test deliverables, approvals and glossary. Next one, sample test document. One sample test document. I will explain just a minute. Not sample test document. I will explain fields. Test plan ID. Some type of unique company generated number to generate uh, just a minute. What is this one? Just a minute. Test plan ID, some type of unique company generated number to identify this test plan. Next, introduction. Describe the purpose of the plan, possibly identifying the level of the plan. Next, test items. Test items. These are things you intend to test within the scope of this test plan. Next, references. References. List all documents that support this test plan. Refer to the actual version, release number of the document as stored in the configuration management system. Next, features to be tested. This is a listing of what is to be tested from the user's viewpoint of what system does. This is not a technical description of the software, but user's view of the functions. Next, features not to be tested. This is a listing of what is not to be tested from both user's viewpoint of what the system does and a configuration management or version control view. This is not a technical description of the software, but user's view of the functions. Next, testing approach. This is your overall test strategy for this test plan. It should be appropriate to the level of the plan, master, acceptance, etc., and should be in agreement with all higher and lower levels of plans. Overall rules and process should be identified. Next, entry criteria, a field in software test plan. It describes when to start testing. Next, exit criteria. It describes when to stop testing. Suspension criteria. It describes when to stop testing temporarily. Next, roles and responsibilities. Roles and responsibilities. Test team or test lead. Test team or test lead and team members' roles and responsibilities. Next, schedule. Schedule for all test activities in this software testing process. Next, training of the application, domain training for any test tools to be used. Next, test environment or lab. It describes required hardware, software for setting up test environment or test lab. Next, test deliverables. List out that what is to be delivered is part of this plan. Next, approvals. We can approve the process as complete and allow the project to proceed to the next level. Next, last one, glossary of terms. Define terms and acronyms used in the document. It can be used to understand the terms used in this plan. Next, test case template. Say, in manual testing, we can prepare test plan, test case, and defect report documents using Excel sheet by using company prescribed template, or if your company uses any test management tool like ALM, Application Lifecycle Management, formerly Quality Center, or Jira, etc. tools, you can prepare your test cases in that test management tool. If no test management tool or defect management tool used in your project, then using Excel file, Excel sheet, and using company prescribed template, you can prepare this one. But nowadays, most of the companies using test management tools or at least defect management tools. Defect management tools only for defect reporting and tracking. Test management tools, test case design and defect management. See, conclusion, defect management is part of test management. Okay, you can use any tool for test management or manually you can use, you can write documents using Excel software. Okay. Test case template. Test case template may vary from one company to another, but purpose same. Here test case ID, test case, I will show example. Test case name, test suite ID or test batch ID, precondition, steps to be executed, executional steps, post condition, expected result, actual result, test result, pass or fail test results, remarks, comments. See one example test case, a sample test case using one online banking functionality. Observe test case ID, an unique name or number. See here IBS, it is project, Internet Banking System underscore PB. PB stands for Personal Banking Module TC001, test case 1. Like this, like IDs you can, unique IDs, understandable IDs, readable IDs you can use. Next, test case name, verify account holder login operation. Test suite ID, personal banking 001. In personal banking, first test suite or you can say test batch. Precondition, existence of personal banking login page. Steps to be executed, enter valid user ID, enter valid password, select start in default accounts. Next, click on login button. Next, post condition, personal banking page, personal banking page. Next, expected result, launches personal banking page with available services. Actual result, personal banking page launched with required services. Test result, by comparing expected result with actual result, pass. Remarks, comments optional. Next, one more important document, defect report. Defect ID. See, already I told you can prepare your defect reports using Excel file by using your company prescribed template, or if your company is using test management tool or at least defect management tool like Bugzilla or Mantis, etc., you can prepare defect reports in your defect management tools. Every tool provides its own template. User means tester can customize the templates. See, important fields are defect ID, defect description, test case ID, reference, tester name, product version, build version, priority, severity, status, reproducible or not, reports, reporting to corresponding person, remarks. Observe a sample defect report, defect ID, FR. Suppose this is project name, flight reservation, USR, user module. In this module, DF001, defect 1. Defect description, agent name is accepting numeric values. Agent name should accept alphabets. It is accepting numeric values. Test case ID, flight reservation user PC004, fourth test case. Tester name Kanakarao, product version 1.0, build version 1.0, priority medium, severity high, status new, reproducible or not, yes. How to reproduce? Launch the application. We are providing steps to developer. By executing these steps, developer can locate that defect. He can easily understand. He or she can easily understand. Steps: launch the application, enter numeric values into agent name field, agent name edit box, enter valid password, click on default button. Next, reporting to XYZ. The reporting is depends on the company. Corresponding developers are development lead. Remarks, comments optional. Thank you.